So I'm going to be talking about essentially like the prerequisites that you need to know to understand generative AI. So I'm going to start with artificial intelligence. So artificial intelligence, essentially, it can be considered a field in its own right. It's like chemistry, geography, history, physics, right? It's its own field. And the aim of this field is essentially develop a computer system that can mimic human intelligence in some sort of way. So machine learning is essentially, I mean, sometimes it's classified as a subfield of AI, but I would say it's more of a toolkit. It's a set of tools where computers can sort of learn from data. And the purpose of it would be to sort of make decisions, and you'll see what I mean in a moment. So, let me just, okay. So, basically, in terms of data, you've got two sorts of data. So either the data is labeled. So in this case, you can see an illustration of, let's see if I can. You can see an illustration of basically data that has like a tag or a label, right? So you've got like, let's say here, a shape of a star, and it says kind of star next to it. So your computer system, your machine learning program will have access to both of these information. So your computer system will have access to the actual data and the label that comes with it. So unlabeled data is data that doesn't come with that tag. So it would be just the shapes in this example without any of the labels. So that would be unlabeled data, right? So that brings us to two forms of learning within machine learning. So let me just go back to this slide. Actually, never mind. So basically, so supervised learning, right? So supervised learning is essentially when you take unlabeled data and input it into your machine learning program. So that's a type of machine learning. So in this scenario, you can see that when we input the labeled data, what the machine learning system is able to do is when it is supplied with a shape of a star, that if you notice, it's not the same. So this is the star that we actually provided to the machine learning algorithm. But as you can see, we can provide different shapes of stars, or actually the same shape of star, but different like types of stars, basically. And the computer will be able to recognize that it's a star, right? So this is what it's trying to do here. And yeah, so this is supervised learning essentially. So it's when you input labeled data into your program. So an example of supervised learning would be something like tumor classification. So this would be like a normal tumor. And so we would input it labeled to our system. So the data, the pieces of data, so the pictures here would be accompanied by a label that says whether it's a normal tumor, or abnormal tumor. And so this is an example of an algorithm that uses supervised learning. So two important terms are classification and regression. So classification usually involves sort of non-numerical data, but not necessarily. So it's kind of when the output of your algorithm is not numerical. So when you categorize data. So going back to this example, so this can be defined as a classification program. So it just classifies it into different groups. It classifies the data into different groups depending on what it is. And the other type of program can be referred to as regression, which focuses on predicting continuous values. And you'll see what I mean in a minute. So some common algorithms of supervised learning are linear regression, naive Bayes classifier, and support vector machines. So don't worry too much about those algorithms. It's just to give you an idea of what else is what's there in terms of supervised learning algorithms. Obviously, it's not limited to this. There are a lot more different types of algorithms, but those are just some of them. So going to unsupervised learning. So unsupervised learning, again, if you focus at the data, you can see that we are just inputting data that doesn't come with a label to our system. So we input it, and then basically so it depends on what we want our model to do. So in some cases, it does make sense to input unlabeled data to our system, to our model. So an example of unsupervised learning problem is something like customer segmentation. So that's quite interesting because, as you can see, let's say like those, let me just, okay. So suppose those are basically a set of customers from like a website or like a blog or whatever, right? So basically, what this algorithm would aim to do, it would basically group those customers based off of sort of similarities that it sees in the group. So suppose the purple ones are all customers that are like of a certain age, right? And the blue ones would be customers that of like a different age, right? So it would classify it regarding that, or maybe it could do that in terms of like gender, right? Or another type of classification would be in terms of like profession or in terms of like location in the world. So that's what this type of algorithm would aim to do. So it would basically see what the similarities are. So it would compare the customers in terms of compare them to each other, and it would group them into clusters based off of that. And so hence the term clustering. So that's another type of like clustering as a term is another type of like common algorithm basically. So you've got different types of clustering. K-means clustering, hierarchical clustering. So those are common algorithms, but again, don't worry too much about them. It's just to give you an overview of what is out there in terms of algorithms. Okay, so we have our first sort of quiz. And so if you guys take a look at this graph closely, I'm just going to explain it real quick. So here you can see the blue dots represent pickup orders, and the orange dots represent delivery orders. And basically, here you can see the total bill amount, so how much the order costed, and the total tip amount, right? And basically, we would like to know whether this is supervised or unsupervised learning. So do you guys, maybe you can like input your answer in the chat. I'll give you guys a few seconds to take a look at the graph. Okay, so this is actually a supervised learning problem because essentially the data is as we mentioned labeled, right? So going back to the slide. So supervised learning uses labeled data. So as you can see, the shape of the star is accompanied by the label star. So going back to our example, you can see that it's basically labeled. So we know which orders, whether it's like pickup or delivery. So that's the label in this case, whether an order is pickup or delivery. Oops. Okay, so another quiz. So yeah, I'll give you guys a few seconds to take a look at the graph. And do you guys think it's supervised or unsupervised learning? Okay, so it looks like most of you guys have it right this time. It is unsupervised learning. So we are looking in this case at the raw data and seeing if it falls into groups. So as opposed to the graph here, it's not labeled, right? So they all kind of have one color. And yeah, so we're just grouping them. So here it's the years at the company and the income. So we're trying to see if there's like a correlation between them. So as you can see here, the algorithm is basically like drawing a line between those two groups. So it can see a sort of like pattern between, so it can basically like, if you look at those points, those data points, it can see that those data points are closer to each other than those data points. And therefore, like there must be some sort of like correlation between them. So this is clustering. This is, so it doesn't specify here what kind of clustering it is, whether it's k-means clustering or otherwise. But yeah, this is an example of clustering. Okay, so we're going to dig deeper a little bit into supervised and unsupervised learning, because this is quite important for the content to come. So supervised learning, well, actually, let's start with unsupervised learning. So you input the data into the model, and it just generates something. It sees what it can do with the data. So generally, you would have to pick what kind of model you would want. So, so for example, k-means clustering or whatever. So the model is up to you, and then you input the data into the model, and you just see what it gives you, basically. So in terms of supervised learning, so you have basically an expected output, and the algorithm knows it from the data. So if I just go back here, if you look at the star or the circle or the rectangle, you've got the star and the label of the star. And so when the algorithm will see one of those shapes, it will compare it to what's called the training data set. So this is what the algorithm was trained with. Okay, so just. Yeah, so this is what the algorithm was trained with. And when you input something different, so a different type of star that's not the same color, it will be able to tell. So basically, this is what's happening. So the algorithm or the model compares the predicted output, so predicts an output, and then it compares it to the expected output. And in the case that there's an error, then it goes back in a loop. Whereas in unsupervised learning, this isn't really the case, because it doesn't have an output that can compare it to begin with. So I'm just going to touch up slightly on deep learning, because it's quite like it is quite a learning curve, and there's a lot more to it, basically. But it's a type of machine learning that is based off of artificial neural networks. So what it basically is that it kind of like mimics the human brain, and that enables it to process like more complex patterns. So neural networks are commonly used in image recognition, and we will be seeing this shortly in our first first interactive activity. So yeah, so usually like complex algorithms are more often based on artificial neural network. And if we go back to um, here, you can see that deep learning is one of the categories of machine learning. And so what we just talked about earlier, right before deep learning, was all the algorithms. So linear regression, support, we just touched slightly on them in the examples. So those are like traditional machine learning models, but deep learning enables us to go deeper. So it doesn't say here that it uses neural networks. It just says the kind of applications, so computer vision, natural language processing, etc. Okay. Okay. So in semi-supervised learning, um, basically a neural network is trained on a small amount of labeled data and a large amount of unlabeled data. Okay. So the labeled data basically helps. So essentially, like usually in practice, it's more difficult to get labeled data. So this would be like a practical solution, because if you can imagine, like labeled data usually is something that you would need to do manually. Yeah. So this is like an efficient solution. It can use like a small amount of labeled data and a larger amount of unlabeled data. And yeah, that would be semi-supervised learning. Okay, so now we'll begin seeing the core of our topic, which is generative AI. Okay, so discriminative and generative AI are basically, so in the course, generative AI, they actually deal with generative AI in the course of in the context of deep learning. So deep learning, generative AI. But actually discriminative and generative AI are more descriptors than they are like actual subfields, right? So a discriminative model is basically used to, so it's what we've seen so far, right? It's used to classify or predict. So you train it on a data set of labeled data or unlabeled data, and then it learns the relationship and it just does what you want it to do. So going back to here, for example, in the unsupervised learning example, you can see that basically like you input the data and then the model just separates it into clusters that see similar, right? But it doesn't give you something of its own. So maybe it'll be clearer here. So for example, in this case, you've got like, let's say a star, and then basically the model, if you give it a picture of a different star, it will be able to tell you that it's a star. But basically, it won't like give you a star of its own. Basically, it won't generate its own star. It will just like work with what you give it, basically. So generative AI basically generates new data. So does anyone maybe can tell us what they think, kind of what field they think generative AI would be useful in? Is there anything you guys can think of? Um, feel free to unmute your mic if you'd like to say something about this. Yes, exactly. So one of the things that it can be used with is, content creation, art, etc. So it does have quite a lot of use cases. So for example, here it says like it can predict the next word in the sequence. So it generates new data basically. Okay. So the way like a general discriminative AI model would work. So again, so this would be our training data. And so in this case, so those are the labels. So in the forms of zeros and ones. So one would be the label of a painting that's a Van Gogh painting. So if it's a Van Gogh painting, it would be classified as one. So here, all of them are Van Gogh paintings, therefore they're one, right? And if they're not Van Gogh paintings, they will be classified, labeled as zero, basically. Okay. So basically, what you would do is that you would input in a discriminative model, you would input something like a painting, and then so in this case, it's a Van Gogh painting, and it would tell you whether or not it is. So it would predict it in this case. But in generative AI, you give it training data, and the model trains on it, but it's able to give you a sample that is different from what you initially trained it with. So yeah, so this step is sort of skipped in generative AI. Yeah, so basically you just put in unstructured content, and then the generative AI model learns patterns and then outputs new content, basically, as opposed to a discriminative AI model. In this case, it's supervised learning because you have data and labels. And so it learns here the relationship between data and labels. And the output here would be the label. So going back to the Van Gogh painting, so those were the labels. And it just outputs the label, basically. Okay, so now we're going to be, let me just share, yeah. So now we're going to be going into our first group activity, which is called, let me just show you guys how it looks like. Basically, this is a software by Google that has been developed by Google. It's called Quick Draw. And what you do is you basically go in, you would click on it here, and you would basically, it would give you like a drawing prompt, and you would draw it. So in this case, if you can see, like this would be like pizza. So it would tell you to draw pizza, and you draw it. And basically, the software will be able to guess what you're drawing. So this is based on neural networks. So as we mentioned, this is deep learning based. So yeah, I'll give you guys a few seconds to scan the code so we can start with the group activity.